Hello all. Ask any embedded engineer on the simplest and the easiest serial communication interface you have worked on. So um, the most answer that you received from engineers is mostly I2C, while UART is the simplest. Most engineers got used to I2C, and many of the people know in and out of it. Now, let us talk about I2C and then see what is an I3C protocol. Now, to give a background, we know I2C is basically a bidirectional half-duplex serial communication interface, and it is basically intended to be used between ICs on a board from one to many basically. And then this particular interface is one of the commonly used interface, and even in a basic microcontroller along with UART you can find I2C. And we know there are several modes: standard mode, fast mode, ultra fast mode. So this I2C starting from 100 kHz can provide communication speeds up to 5 megahertz. That means the clock frequency basically can go up to 5 megahertz. So one of the important terminology in I2C is master-slave communication, where there will be master and then there will be slave, and master initiates everything to the slave, and then slave responds as per the information requested by master. There is no slave to slave communication, only master would be present. So it's all basically, we can say that mainly the master is the guy who is in control of the things. And we know basically I2C is a open drain, and for this open drain pull up is required. The major disadvantage with this is that when you add a pull up, that adds to the power consumption, even though it will be minimal. But still, if you have applications where you have battery, then definitely even a nanoamps of current would matter there, right? And basically that's what is very important. And then one more important point here is if a user has an option such that if you can keep the slave in sleep mode for some time and then use it as required, then definitely it cannot happen without any additional pins. So either the power should be off, or any additional circuitry need to be designed. So definitely that's not an option at the current scenario. Now ask any engineer what is the difference between I2C and SPI, or I2C and any other communication protocol. The first thing they start telling is I2C is a two-wire communication protocol. It has a minimal pinout. Now, does that hold good with the current complex designs that we are working on? Definitely no. So the designs are becoming complex these days, and then also the slaves wanted to talk rather than only masters controlling them. So in that case, the slaves need to have some mechanism to talk to the master. So such mechanism are like interrupt pins or the reset pins that you see on these slave ICs. And when you have interrupt and the reset pins along with the clock and the data. That means I2C is now no more a 2-pin interface. Basically you need another 2 pins so that the slave is able to communicate independent of master initiating it. So that means you need additional 2 pins, and these interrupts and interrupt pin and the reset pin generally you connect to a GPIO. That means you need more pins. It occupies more space on the PCB, and the pinout of the processor or the controller you're using has increased. So definitely if your slave wants to talk, your advantage of the pinout, which we used to claim that this is the simplest two-way interface, is no more there. Now the same I2C interface is used across different devices, whether it be any PROM, simply PROM, or whether it be any devices for which configuration is required, like the example LCD backlight control, or the accelerometer, gyroscope, all these which we use, and then the battery chargers, fuel gauges. So there are many things on the board where I2C is used, and the sensors these days have the simplest I2C interface. So that means as the IoT is in boom, and there are several applications on IoT, which means IoT itself means at a lower level there is more of sensorization and data rate that is happening. That means there are more I2C devices that are introduced, more basically sensors introduced, and hence I2C are introduced. And with more and more I2C devices being introduced, there are chances that the address might get conflict, and also the capacitance of the bus might increase as the number of devices increase. So this is again a disadvantage as the number of slaves has increased. So considering that the I2C protocol demands have increased these days with the IoT. Now one major advantage, as we increase the number of devices, there is always a chance of errors. So current I2C doesn't have a basically error checking mechanism. So that's another disadvantage. So if you bring all these together, if you want a battery operated device, there is a power consumption that is happening. If you have a number of slave devices, there is no way you can check errors and then control the addresses. Address conflicts might happen. And then if you want the slave to talk, you cannot do it without the additional pins from the slave side, and definitely the slave to slave communication is not at all there. So there are disadvantages with the current I2C. Now for a design engineer who is using I2C in a simple application, or with some 3 to 4 slaves on the board, or for that case some 5 up to 10, you should not have issues. But as the demands increase, where slaves want to talk, you need to have lower power, and you must be able to manage the address conflict. As these kind of requirements do come into picture, there are additional things that are additional specifications which need to be modified and introduced so that you can manage these things. Now this is where NXP is talking about I3C along with the MIPI aliens. I3C is also a serial communication interface, which is again a two-wire interface. I3C is coming into picture considering some of the drawbacks that are seen with the I2C. Now this I3C is basically push-pull rather than open drain. That means you don't need any additional external resistor which we use for a standard I2C. That means low power consumption, And then definitely this is backward compatible with I2C. That means if you have the slaves which are I3C, definitely they can switch back to I2C, and then basically the backward compatibility is maintained. Now we have talked about the maximum clock frequency 5 MHz there. Here the I3C can operate up to 12.5 MHz and the data rates up to 30 Mbps. That means when you say 12.5 MHz and data rate 30 Mbps, definitely there is a dual data rate that is coming in. So the you just read the specs on how the data rate is maintained and then how dual data rate is scoped up in the designs. And one major differentiation with respect to I2C is I3C has a address which is dynamically assigned. That means the master can assign the address once it is connected. So master tries to scan and see what are all the devices, and then provide addresses to them, and hence the priority of reading them. So that is one important thing, whereas in I2C the address is fixed, where we go through the internal address register and then use the pins that are there by hard coding those specific address bits. And here we can connect up to 11 devices maximum, which is again depending on the protocol deficiency. So this has to do more with the protocol coping up with the number of devices. So that at the moment it is restricted to a maximum of 11 devices. One advantage here is that the slave can initiate the communication, as we said in the previous one, without any additional pins. So that means a slave can randomly send data to master based on its requirement. And in I2C, one disadvantage is that the master cannot stop the communication. Only the slave can stop the communication. Now here the master can stop the communication. So if we have to go through the protocol to see and how this is happening, and then one thing here is that in I2C it is a multi-master multi-slave communication, whereas I3C is a single master communication. And slave to slave communication is also possible in I3C. As we said previously, if the slave wants to talk, there are additional pins required like interrupt and reset for I2C, but here the same requirement would be done using the data and clock pins itself without the need for interrupt and reset. So one major thing here is that for the slave to perform some of its internal activities, the master would be sending a clock signal at regular interval, just randomly, so that the clock can perform, the slave can perform any internal operations that is required. And one more advantage is basically the slaves are hot pluggable. Whereas in I2C, if you see, unless the master knows what it is, what the slave is, what is its configuration, it cannot talk. But here, a slave can come in at any point of time, and then master can assign address to it and communicate as per the requirement. So a very flexible communication mechanism. Right now, we do not see many applications being used, but this is a protocol under continuous improvement, and even the slaves we use, or the sensors basically, mostly we use I2C. So I3C could be a interface in demand in future. Please let us know if you have any questions. Please visit the NXP website and its standard for details of this I3C. Please like and subscribe our channel. Thank you.